Welcome to JSP's YouTube channel. In this, we are discussing Chapter 4 Q Data Structure. Chapter 4 Q Data Structure includes the following topics: Introduction to Q, Operations on Q, Implementation of Q using Python, Introduction to DEC, Implementation of DEC using Python. From examination point of view, the weightage of this particular chapter is 8 marks, one question under MCQ, one 2 mark question, and one 5 mark questions will appear in the final exam. The summary of this chapter is: a queue is an ordered linear data structure following FIFO strategy. Please take care of the FIFO strategy. What is the expansion of FIFO strategy? FIFO means first in, first out. That means the element inserted first can be taken out first. Inserted element can be first out element. So FIFO principle is the queue data structure. Then you have to concentrate on the different applications of queue in real life and also in computer science. Then, what are the structure and operations of queue must be studied. The front and the rear are used to indicate beginning and end of a queue. The front and the rear or rear. Front means beginning, rear means end of the queue. Insertion in a queue happens at the rear end. Underline this. Insertion means whenever we add any element into the queue, then it can be inserted from the rear end. And the removal or deletion of an element happens at the front of the queue. So inserting an element, rear end, removing an element is from the front end. The insertion operation is known as NQ. Please underline this. In stack it is called push operation. In queue it is called as NQ operation. That is, whenever we insert any new element into the queue, this operation is known as NQ, and deletion operation is known as DQ. Normally, the student will get confusion with the DQ. He may use DQ as double-ended Q. So here we are discussing about the operation on Q. There are two basic operation performed on a Q, that is called NQ and DQ. To support NQ and DQ operations, is empty, is full, and peak operations are used. So the students has to study the NQ, what is NQ, algorithm of NQ, and the Python programming block for NQ operation. Then the student has to study what is DQ algorithm, and the Python program code for DQ function. The student should also study the isEmpty function, isFull function, and the peak function in Q. It is important. Then we move on to DEC. What is deck? Deck is a version of queue which allows insertion and deletion at both the ends. Deck is another data structure, is another version of queue. What is the difference between a queue and a deck? In the queue, there will be front and the rear end. The front end is used to remove the element, rear end is used to add the element. But in deck, the front end can be used to insert the element or remove the element. Similarly, the deck also has the rear end. The rear end in deck can be used to add the element and also to remove the element. The deck can support both stack and queue operations. Other operations supported by deck are insert front, insert rear, delete front, delete rear, get front, get rear, is empty and is full. So, students, study all these functions and also you have to study the applications of deck. Now, we'll study how the questions may appear in the examination. Under 1 mark category, the question is like this. Deck is a version of queue which allows insertion and deletion at front end, rear end, both ends, not both ends. What is the answer? As you know, the deck is a version of queue which allows insertion and deletion at both the ends. The correct answer is C. Another question. An arrangement of linear data structure in which addition and removal of elements can happen from any end is known as the options are stack, queue, deck, enqueue. The correct answer is deck. Why deck? Why can't we stack? Addition and removal of elements can happen from any end is known as deck. In stack, only top end will be there. In queue, of course, will be front and rear end, but the purpose of front end and the rear end is limited to remove and add the element. Whereas the deck is the correct answer and NQ is an operation. Hence, it is incorrect. The correct answer is deck. C. The next question, the operations used to view elements at the front of the queue without removing it from the queue is normally DQ removes the element but it doesn't show the element. Even if it shows the element, but after removing it shows the element. Then what is the answer? DQ, the DQ removes the element. The peak, yes, the peak operation is used to view elements at the front of the queue without removing it from the queue. The question may also come in this form assertion. As we have already known from the previous chapter stack, how you have to decide the answer in getting the question using assertion and reason. What is the assertion statement? First read the assertion and decide whether it is correct or incorrect. The queue is a non-linear data structure. Underline non-linear data structure. Is the queue linear data structure or a non-linear data structure? Queue is a linear data structure and it is not a non-linear data structure. Therefore, the assertion is incorrect. Then what is the reason? The reason is insertion and deletion takes place at same end. This is also incorrect with reference to Q. This reason may be corrected for a deck, but definitely it is incorrect for Q because insertion happens at the rear end, deletion takes place at the front, not at the same end. Because the same end is actually present in the stack, certainly not in the queue or deck. So A is false and R is A is false and R is not correct explanation. So both are incorrect. Another question is which data structure allows insertion and deletion from both ends? Insertion and deletion at the front end, insertion and deletion at the back end. That is the meaning of this question. What is the answer? The options stack, incorrect, queue, incorrect, deck, yes, it is correct. 2 mark questions are like this. One 2 mark question you will get from this chapter. The question is write any two applications of queues in computer science. See, underline this computer science. Read the question properly. Now, when they specifically ask the computer science field, then you have to mention at least any three applications of queues in computer science. Another question. For the elements Z, X, C, perform NQ and DQ operations. Then what is the answer is already given to you. So NQZ, NQX, NQC you have to write. Then DQ, DQ and DQ three times you have to write. So at the end, what will be the status of the queue, that also you have to show. Then the next question is list out two operations on double-ended queue. List out two operations that can be from any of the 7 operations. You can consider any two operations. No, I suggest you please write three operations of double-ended queue, nothing but a deck. The next question is write the implementation of DQ. DQ is a function. DQ is a operation. The DQ in Q is known for removing an element. So then you must write the Python programming code for the DQ operation. Write the operations performed on Q. So what are the different operations performed on Q? So NQ and DQ is just write only the name of the operations of NQ, DQ, is empty, size, peak or top, like this, the different operations, whatever is present in the queue that you must mention. Then under 5 marks category, how the questions appear from this chapter. Write an algorithm to check whether a string is palindrome or not using deck. So dear students, you have to study one algorithm, that is palindrome. A string is a palindrome or not using deck. Please study and practice. The next question is define deck. Explain the operations on deck. What is a deck? Explain the operations on deck. You have to explain any 4 operations of deck, that is in insert front, remove friend, insert rare, remove rare, is empty, like this. So, what is the operations do? What is the meaning of those operations? That you have to write at least in one or two sentences. Then, the next question is write a Python program to test whether a given string str stored in a double ended queue, the queue or deck, is a palindrome or not. So, it is same as the first question. So, here deck is given, here double-ended queue is given, both are one and the same. Okay, so remember you have to practice the palindrome or not using deck, a algorithm and also a Python program. Both you have to practice. What is deck? Explain the various operations performed on deck. This is same of this, that is define deck, explain the operations on deck. So any five operations is compulsory, and what is deck you have to explain in one or two sentences. Give the applications of queues in computer science. So how many applications you are going to write? Five queue applications in computer science. No. Six application in queues in computer science is most appropriate.